All right. Recording to the cloud.
All right, let's see if I can find out where I put my file. Okay, it's not on there. I'll get it. Hang on.
Okay, take your time. So I see Zach is here. He emailed us earlier this week that he wanted to join the meeting. Hello there, Zach.
Hey, I don't know if you can hear me.
We can hear you, yes.
Okay, perfect.
Welcome.
Thank you. Yeah, next time I'll have a camera.
No problem.
And let's see. Let's try this. All right, can you see that? It should be a...
Yeah, we can see it.
All right. Well, let me know when you want to go.
Whenever you're ready.
All right. All right, well, welcome everybody. This is part 2 of my OmniDrive presentation. Last month, I showed you the 3-wheel OmniDrive robot that I had that ran around on the floor and used OmniDrive or holonomic drive, vector drive, that all kind of words for the same thing, so that it could go in any direction at will. And I showed you that on a little robot that ran around on the floor. So this is part 2 using a quadcopter. So instead of just 2 dimensions, where I was able to get away with using the rate gyro for heading hold stabilization, in this one we're going to use the full benefits of an IMU and a couple other sensors to move a quadcopter around in 3-dimensional space. And I wanted to give you a little history of this. So let's talk first about the original, which was the Dragon Flyer. This was about, it's been probably close to 20 years ago. The first ever quadcopter was shown, and it was called the Dragon Flyer. And it's a cute little play on words. The spelling with the D-R-A-G-A-N is not a mistake. I'll show you in a minute. So the Dragon Flyer was first shown on Ripley's Believe It or Not, that TV show from 20 years ago. And so I've got a little clip. I apologize in advance for the graininess of this, but it was the only one I was able to find. So here we go, and you'll recognize Superman as he introduces the first ever quadcopter.
You're watching Ripley's Believe It or Not.
Dr. Bruce?
Yeah.
All we see is your File Explorer.
File Explorer. You're not seeing the video.
No, we see your File Explorer.
It's going to be annoying.
You're sharing just the File Explorer.
Stop sharing and reshare the video.
Okay.
Or share your screen.
Here.
There we go.
Now are you seeing it?
Yep.
Now we see it.
Great, okay. I forget this guy's name, Dean somebody. He played Superboy or Superman in one of those TV series.
You can find one-of-a-kind artifacts and new arrivals on the cutting edge of technology as well. like this. This is the first four-rotor helicopter. What looks like a toy is actually an engineering breakthrough. And now helicopter manufacturers are scrambling to try and replicate this unbelievably stable design on a large scale. They're masters.
In the meantime, this prototype is equipped with a camera, creating a steady spy in the sky. The next wave in surveillance technology.
And now, here's something else.
So that was the first ever quadcopter. And that really kind of shook the world here a little bit because no one had ever done this before. And all of a sudden, of course, the military was interested, police agencies were interested, but it had commercial value for things like building inspections, looking at the roof, that kind of thing. But no one else knew how to make one. These guys had really done something incredibly creative. So here's the guy who did it. And his name really is Xenon Dragon. And that's where the name Dragonflyer came from. As you might suspect by the name, he's Canadian. Well, okay, that's a bit of a joke, but he actually is Canadian. And I was able to email him, and we had quite a few conversations back and forth. And I wanted to see if I could make my own four-rotor quadcopter. So the first thing is how it works, and it's very clever. You've got four rotors. Can you see my cursor?
Yes.
Okay, good. I'll use that as a pointer. Two of the rotors go clockwise, and two of the rotors go counterclockwise. The reason that they have it set up like this is if they're all four going at the same speed, you're canceling angular momentum. So the thing doesn't rotate. And if you're having all four of them going at the same speed and going fast enough, it'll lift straight up in the air. Once it's up in the air, if you slow the two in the back down and you speed the two up here in front, speed them up by the exact same amount that you slowed these down, this part will tilt a little bit. The sum total is the same. So it doesn't rotate. It doesn't lose altitude, but it tilts a little bit. And if these are going faster and these are going slower, it's going to move in this direction, and vice versa. If, on the other hand, you speed up these two and slow these two down, it's going to move to the right. And if you instead speed up the ones that are labeled across from each other and slow these two down, you'll have the thing turning in clockwise direction because of the preservation of angular momentum. And you can make it go the other way just as easily. So with minimal control of very slight changes in speeds and doing it in a balanced way, you maintain stability, maintain altitude, and can control this to go in any direction. That's why it's an omni-drive vehicle. So the control of this is very simple, really. You have the speeds of the four rotors. You're changing the speeds in pairs, and you can make it go in any direction. Increasing all four makes it go higher. Decreasing all four makes it go lower. Any questions about the physics? That's as simple as it gets.
Okay, if you slow down 1 and 3, does it rotate?
Yes. You
Yeah.
slow down, you always do all 4. So you slow down 1 and 3. Is that what you said, Ben?
Yes, yes.
Slow down 1 and 3. You speed up 2 and 4. So
And you would,
the sum total hasn't changed.
right.
So the thrust hasn't changed, but you slow these down, speed these up, it will rotate counterclockwise,
And vice versa.
and vice versa. Any other questions? It's a brilliant little system.
So,
And you can just see how easy this would be to control.
so if you slow down all of them, then you're not moving as much air, so it would tend to drop a little bit then.
Yes,
And then if you speed them up, it would circulate more air underneath and give it more lift then.
yes.
Okay.
Exactly. Now, there's a couple of little things that are different about this than the robots we have running around on the floor. If you remember in physics class, the professor always said, ignore friction. Well, in this particular example, when this thing is airborne, it's almost on a frictionless environment. It's kind of like playing air hockey, you know, little hockey pucks on the air table. Once you get this thing moving, if you want it to stop, you have to go the opposite direction temporarily. You have to actively stop it, or it'll just keep going because there's almost no friction up there. The second thing that isn't so obvious until you fly the first time is that these little fans are generating a lot of air pushing down, and that air is turbulent air. So until this thing is lifted off and gotten away from that turbulence, it's very unstable. And that turbulent air that is generated in the first foot or so is called prop wash. And the helicopter pilots, real helicopter pilots, know all about this. The takeoff and landing is real tricky the last yard or so because of prop wash.
And the
Same with this, smaller distance. So you've got prop wash to worry about. You've got the lack of friction. So, you know, once you get something in motion, it's going to continue in motion like Newton's law. But otherwise, the geometry of this is really nice to think about and really nice to play with.
So is prop wash the thing that is essentially the big concern during takeoff and landing then, but once it's airborne, you don't have that problem because you're not near a surface?
Yes, yes.
There's an exception. If it gets close to a wall, you can develop something called cyclic force. And that's the air that's turbulent comes down and it'll climb the wall and come back up the top. And that'll push it one way or the other and can force it into a wall.
And you're going to see a little bit of that in one of these videos. So yes, thank you.
I can tell you another cool story too. In the Navy, in the 70s, everybody was using air pallets. So they did an air pallet. It was like the hockey table. It pressed air underneath and that would let you move stuff basically frictionless. So some genius in the Navy department decided that would be real good on aircraft carriers and on the tender I was on. But what they didn't think about was when you're at sea on a ship, that floor isn't flat anymore. So one of the young men got a big pallet full of stuff and he got it up on the air pallet and the ship rolled. and it went sailing across the floor at about 60 miles an hour and slammed into an airplane and nearly destroyed it.
Yeah.
So
Yeah, you got no friction. We start to take that for granted. So I decided I would try to make one of these myself. Again, this is about 20 years ago. And I used the BX24, which was a microcontroller upgrade, pin for pin compatible with the basic stamp, but it had some features. It had more speed, more memory. It had built-in floating point math, and it allowed you to do multitasking, all in a device that was the size of a basic stamp. So I called it a BX Flyer. And here's a picture of what I ended up coming up with after 2 years of working on this. And I had a lot of help from Steve Boris, who's down in San Diego. He was one of our past presidents for the robotics group. And Alex Brown, who comes regularly to our meetings and was also past president. And they both helped me a lot with trying to get this thing to work. I didn't have the benefit of an IMU. I didn't have rate gyros. I didn't have brushless motors. And basically, I'm amazed this thing worked at all, but it did get off the ground. It didn't do anything else. It went up and came down. I was able to demonstrate it at the Robotics Club 20 years ago, but it never really was, I wouldn't call it autonomous. It went up, it came down, that's about as far as it went. But if you look up BX Flyer in Google, you'll find an article still on the web about this. The interesting other problem was these rotors got going, and you'll notice there's no guard on the rotor. So if this thing got in the prop wash and one of the rotors touched the floor, or it drifted and one of the rotors touched the wall, it would just spin into the obstacle and self-destruct. And I spent the next week rebuilding this whole thing. So unfortunately, it was unstable. It flew a couple times, but it also managed to self-destruct more times than I care to count. So 10 years passed, and Parrot came out with an AR drone. This would be now 10 years ago. And I decided to hack it, go back to the drone, hack it, and I used a Linux-based computer laptop with ROS to interface to the drone. And the drone has a downward pointing camera. So I transmitted the image from the camera back to the laptop. And I was able to try to get this thing to do line following and to do it autonomously. So here's a little video. Can you see this on the screen?
Yes, we can.
Okay. Here I am demonstrating the AR drone at one of our RSSC meetings. I'm holding a controller which simply sets it into motion and turns it on and off. It's going to hover autonomously and then land. But I'll show you more here in a minute. So let's take a quick look. It's hovering by itself. So there it's landing. Now, part of the reason I wanted to show this segment, this was part of the presentation I did at the meeting. And I listed down here what was required to get this thing to work. It was running on Linux, specifically Ubuntu. It was using ROS as the interface between my PC and the drone. I was using OpenCV with a combination of linear algebra and matrix vision to do the camera, and using the camera to look for a line on the floor, which I'll show you. It's written in C and Python, and the link is with the drone as an access point. The link is a Wi-Fi link. So to get this working, I needed all of these elements to be coordinated, but you'll see we got it to work. Now, I had help with this from Gary Malalepsy, who's still a very active member of the club, and we got it to work. So here I am in the hallway. Here's the drone, and here's my laptop. I'm getting it set up. There's a 15 or 20 foot strip of blue painter's tape. So what we have is the drone with a downward pointing camera that's going to look for this strip on the floor, take off, follow the line, get to the end, and land autonomously. So here we go. This is down the hallway of, I think we're still at Cal State Fullerton at this point. Here we go. And that was what Les was talking about. It finds the line. As soon as it finds the line, it's flowing all over the place. It goes. And it managed to do that, even though the wind was blowing it all over the place. It was not only blowing off the floor, it was blowing off the walls, just like Les said. But it was correcting to get back on the line. So this was the first autonomous quadcopter that we had that we demonstrated, the only one. And coincidentally, it was my first line following robot.
Wow.
I had quite a discussion with Xenon Dragon. I wanted them to make the robot as autonomous as possible, so someone without any real skill could fly it doing what they call fly-by-wire. And he argued that RC helicopter enthusiasts wanted the challenge. And he didn't want to make it something that was easy to fly. So we had a kind of a agreement to disagree. I think they've since changed that. In order to get an RC helicopter to hover, it takes about 50 hours of practice. And nobody really, if you're going to be in law enforcement or military, you You don't want that. You want something that's easy to fly, semi-autonomous, and that you're giving some external commands. Notice also this does have the protective rings around it, so that saved a lot of crashes. Well, that was about 10 years ago, and it was a lot of work to get it to do just what it did. So I did other projects in the meantime. But here recently, I was invited by RoboLink, a company down in San Diego, to come down and give a talk and see their codrone Pro. This is the first, and I think currently the only, Arduino-based drone, and it can be programmed to be autonomous. So this is what it looks like. It's really small. It's got these kind of neat little eyes on it. The 4 rotors, rotor guards, runs on a tiny little lithium battery. And it'll fly for about 8 minutes on one charge. Takes about 40 minutes to charge it. It uses the 3-axis gyro and 3-axis accelerometer. It says for altitude control, that's not right. This is the IMU. This is what stabilizes it. It says it has a barometer. No, it doesn't. It has an IR pointing down. And so it's using an IR measuring device to tell how far off the floor it is. And that gives you the altitude. And it has an optical flow sensor. So if you put this thing in hovering mode, it uses the optical flow sensor to tell if it's stable or starting to drift side to side. You know, we're getting somebody's feedback here, or somebody's.
Could everybody mute their mics unless you have a question?
Yeah, still there. That was it. Good. So here's what it looks like from top-down view. And they've drawn in the arrows showing you the direction of spin, just like the diagram I showed you at the beginning. So this motor goes clockwise, this one goes clockwise. The other two go the opposite direction, counterclockwise, counterclockwise. And by having them set up in this alternating spin fashion, you get cancellation of angular momentum. And if you turn them all on, and you turn them all on at the same speed, the thing goes up. If you make these go faster and these go slower, it starts to turn in yaw motion, and it would go clockwise. If you speed these two up and slow these two down, it'll go forward. And if you speed these two up and slow these two down, it'll go to the left. So you can control all the motions just by controlling the rotors. It comes with, it comes ready to go, already assembled out of the box. But it comes with this real clunky little joystick controller, but it's more than a joystick. There are 2 joysticks and a breadboard type of a thing, but it's got a microcontroller on it. And this is an Arduino compatible Arduino IDE programmable microcontroller through the little USB port. You assemble this, you just screw a couple things on and plug in the wires. It's very simple, there's no soldering. And this is linked to the drone by Bluetooth. The flight controls, the programming is done on this controller, but then everything is carried out on the drone. So what does some of that look like? Well, the first thing you do is you include the drone library and you get into the Arduino Setup. You set up communications between the controller board and the drone. It's a serial link. You connect with the nearest drone, which you hope is yours. You can set an address in case there's others. And you put it into flight mode. So these are the four setup instructions that you would do for every program. And then what I did was I went into my void loop and you check to see if pairing is true. Means it's paired with the controller. This is set up when it's auto connected. The instructions are very easy. Take off, hover for 3 seconds, go, and you specify a direction, or you can specify coordinates. When I say coordinates, I mean yaw, pitch, roll, thrust. This is a forward command for 3 seconds. Then hover for 3 seconds, and then land. And then stop, don't do this again, for 60,000 milliseconds. That's just enough so I can get over there and grab it and turn it off. In between, I wrote a little routine that reads some of the buttons on that controller. So if I push one of the buttons specifically, I have a little routine that'll just force it to land. This is my kill switch. So if it takes off and I push the button, it'll land immediately. It stops. Or if it takes off and hovers and I kill it, it lands. I cannot, with these particular primitives, I can't interrupt them once they're going. But while it's going from one command to the next, I can stop it. And so I put that kill switch in between every command. Now, you can actually get into more primitives and build it into the commands, but it's more lines of code. It's not quite as easy to read. This works fine. So it's going to, when it executes this, and you'll see, this is autonomous, right? It's not doing anything with the joysticks. It's going to take off, hover, go forward. After 3 seconds, go back into hover, and then land. 3 seconds was about 15 feet. So last month, I showed you my little robot on the ground. And the robot went 10 feet in a straight line using the rate gyro for heading hold. This is going to use the IMU for heading hold. And I want it to go 15 feet and land. So here we are. Let's take a look. too bad. It was off by about 6 inches, it looks like. So for a really simple program, and I didn't do any significant tuning or whatever, it came pretty close to the mark. Any questions about this part? I just have one more video to show you. So the other thing I showed you with my omnidirectional robot was it making a square. And you can think about that. How would you do that with this particular setup? Well, you go forward for a certain period of time. Then you go to the right. Then you go backwards. Then you go to the left. And you should end up pretty much where you started from. Should be a square, right? Well, let's see.
That would be in the air without friction. You would end up doing a circle.
But it's going straight. And it's hovering at the corners. It started about here, and it ended up a little bit off. But you may have noticed that it also rotated a little bit. So this has a little bit of gyro drift, more than my other robot did. But all in all, not bad. You could probably correct that some with adjusting the trim settings, which I didn't. So when it started this part of the journey, instead of going straight back to the beginning, it was already a little bit twisted and rotated, and so it ended up slightly off of its starting point. But it's heading pretty much facing forward the whole time. So just for the heck of it, let's just watch that one more time. Pay attention to where it starts and where it ends up. Starting right there. So I missed a little bit, but pretty good for something that doesn't have external mapping or any other kind of external beacons or boundaries. So it's using the IMU to control its roll, pitch, and yaw. It's using the downward pointing IR for measuring its altitude. And it's using its optical flow sensor, very much like the optical flow sensor that Ben was talking about at a couple of meetings ago, to make sure that it's going in a straight line when it goes forward or to the side. The optical flow sensor is not very good at correcting for yaw rotation, but it's real good at looking for movement in a straight X or Y direction.
So Bruce, a brief question then. Do sort of these air currents that are not uniform, that it flows through, if there's wind in the room or whatever, might cause differential air currents, Do those kind of overpower the gyro a bit so that it doesn't stay quite as stable as it would under, you know, other conditions?
Okay, so if it's fairly minor wind flow or turbulence, this thing can correct for that. But it's made to fly indoors. You can't fly it outside. It's not going to fly in the wind. So any significant breeze, any real wind would in fact just throw this thing completely.
It's probably worth trying to fly it with the fan turned on, you know, I mean, just create a flow of air and see if anything changes. I would bet that nothing will change. And my feeling is that it uses that optical sensor, the downward optical sensor, as odometry sensor. So it actually accounts for the distance and probably direction.
Sergey, that's a good point, and I'm not sure about that. That would be a good way to test it. I know it uses the optical flow sensor for remaining stationary in place while it's hovering. Theoretically, it should be able to use it for the odometry, but I don't know if it does.
So one other question about the control system of this. In your code, you had the hover, the takeoff, the land, and the move forward, and you may even have other primitives. Do each of those primitives then contain all the math that has to do with the gyro and, you know, and the stuff that has to do with your control system that may be additional to the gyro?
Yes, in a word, yes.
Okay.
These are super commands. They will send the command. It's fly-by-wire, right? The drone is flying itself. You're giving it, I hesitate to even say commands. You're giving it requests to take off, hover, go forward. And it's making those, it's turning those into reality. So there is another microcontroller on board the drone, and the drone is doing all the math on board to figure out how to do all these things. Integrate the sensor data, do the sensor fusion from the gyros, the accelerometers, the IR sensor, and the optical flow sensor to make your command become a reality.
Well, it looks from your code here that this is essentially autonomous code other than your read buttons command, which is your kill switch. That it looks like you do that with the communication to the drone from your handheld controller. But the other ones, the takeoff, hover, and all that, seems like it's all kind of built-in code with the is that on the controller also then? But you don't actually manipulate that once it's set in motion. You only manipulate the read buttons, essentially. Is that correct?
I think if I followed what you said, yes, that is correct.
Okay.
This code is running on the controller board in my hand.
Yeah, and it's then being communicated up to the drone then.
By Bluetooth.
Yeah, at 115 kilobaud per second. But so you're not really, you've already programmed that autonomous control in there except for the read button, which is your kill switch that you have manual control over.
That is correct. I didn't program this. I'd like to take credit for it. It comes in the codrone library.
Oh, okay.
And you include that at the beginning of setup.
Okay, very good.
So it's really easy.
Yeah, you could create other kinds of code to do whatever you wanted to do, like your square that you did, of course, you know, things of that sort, right?
Absolutely. So these are the built-in, these are some of the built-in commands. There are other commands that get down to more primitive, like reading those sensor values.
Okay.
So you could write your own hover code. You could write your own landing code. I've been tempted to do this because it doesn't land very elegantly. It kind of crash lands when it lands.
So
But
you could modify the given code then. They give you the source code for it, and you could modify that according to your own fine tuning if you'd like.
you would just write your own function the way I wrote read buttons.
Yeah.
And instead of codrone land, you'd have my land.
Right. Right. Got it.
And then you could have your own function to land or take off or go forward.
Dr. Bruce, this is Jim.
Hey, Jim. Oh, you just cut out. Well, Jim was there, but he just cut out. Maybe he'll reconnect.
I see him there, but
Yeah, kind of, his screen froze.
yeah.
Let me ask a question while we're waiting for him to come in.
Yes, hi, Bob.
Yeah, hi. Dr. Bruce, I tuned in late. So could you tell me the official name of this particular drone?
Codrone.
Okay. Okay,
And
thank you.
And this one is actually the Codrone Pro.
Oh,
The Pro means that in addition to the ready to fly drone, you also get the, where did it go? The little handheld controller kit that has the microcontroller on it. Now, the company that provides this is Robolink in San Diego. I bought it through Amazon. You can buy it directly through Robolink. Their objective in having this is to teach kids programming. So I don't think, I think a kid could probably, you know, a 10-year-old kid could probably put this together without adult supervision. But starting to write the code, I think the kid would need a little bit of help knowing how to do this. It's not hard. And once you see forward for 3 seconds, you change it to 5 and see what happens.
Make the bunnies hover.
And so I think the idea is that with a little bit of supervision, you could get a kid writing some fairly sophisticated drone operations. And they have suggested challenges: take off, land on a bullseye target somewhere across the room, or take off and fly through a hoop, or fly through 2 or 3 hoops, and see if you can make it, you know, write the code to make it do all that.
What's the approximate ballpark cost for this thing?
It's under 200.
Thank you.
And I will say they also, I mentioned that the flight time's about 7 or 8 minutes. That doesn't sound like a long time, but you saw my 2 videos. It's in the air for 30 seconds. It's not flying, you can put this into an RC mode and you can fly it like an RC drone. That's not the point. You know, there are cheaper ones. You can get toys that'll fly longer and cheaper. This is about the programming. So you can get 7, 8 minutes, which is several flights out of this. And you can buy spare batteries and swap them out so you can get lots of flight time.
Things have come a long way from the earlier drones, obviously.
You know, Jim, this is just mind-boggling. The first one was just impossible. And when they showed that on Ripley's Believe It or Not, it was because it was impossible. The military couldn't get it to work. Eventually they did, but it wasn't something that was trivial. Then the company Parrot Drone, got something that worked as an RC. But to get it to work in a programmed fashion was a major, major effort. And now it's something that you do on an Arduino, and it works out of the box. So I think this is really an amazing thing for people to look into. And maybe we could have, if people are interested, have some of our own competitions, you know, flying from point A to point B, going through hoops, go through an obstacle course. There's all kinds of possibilities with this.
So Bruce, what is your thoughts about how you might modify your landing code in order to be smoother? What are some of the considerations you would program in on that?
Well, the first thing I would do is I'd check that IR sensor, find out how far off the ground am I really, because you can adjust it. You know, when you're in RC mode, you set the thrust and you make it go up. When you take your hand off the joystick, it hovers wherever it is. It's really stable. It's really kind of cool. So let's say you're 3 feet off the ground and now you want to land. Well, the landing is going to take longer, and the approach to land is going to be different than if you're 2 feet off the ground or 6 feet off the ground. So the first thing I would do is I'd measure the IR reading, and then I would set my descent accordingly and shut the thing off when I got to the bottom. It doesn't seem to take that into account at this point. Now, I will say that although the landings, the way this is set, the landings are kind of bumpy, but the thing is held up really well. You know, I can't tell you how many times my original BX flyer crashed. I mean, there were times when I got it in the air for 3 seconds and then had to rebuild it. This thing's just, you know, it's been really nice. So it's durable. I mean, you can't be rough with it, but it's durable. It's easy to program. It's been a very nice Arduino-based project.
What kind of batteries does it use? Is it really these light lithium type batteries, or?
Yes. They're little, I don't have a picture of it, but if you go to their website, you'll see they're little rectangular shaped lithium batteries. And I think they're just 3.7 volts. I don't think they're very much. As I said, you can get spare batteries so you can get better flight times. But I don't have a picture of the battery.
website does say it has a barometer, just like you're saying.
It does. It does. It isn't. And I read that and I thought, come on. My house is on top of a hill. We're at 2,700 feet. I don't believe that 2,700 and 2,703 is enough air pressure difference for this barometer, any barometer, to tell you that you're 3 feet off the ground. I mean, a barometer, they said that. It's got to be the IR sensor here. And they're using it for altitude control.
Well, I
They
mean,
say they say they're using the IMU for altitude, but that's not right. It's for using it for roll, pitch, and yaw.
I mean, I had a hiking watch, and it could go, and it was barometer, and it could, it was like, I think 20, this was years ago, but it was 20 feet accuracy or precision, but they're probably better now.
Yeah, but this thing's flying a meter off the ground. So 0 to 1 meter in a barometer at 2,700 feet. I don't think it's going to give you altitude control. It's using the IR range sensor.
What's the maximum height that you've taken your little experimental device up to?
Not well. I haven't tried. I've got a couple of 14-foot ceilings, and one of these days I'll get brave enough. Right now, the highest I've had is about 6 feet off the ground.
So you do this all inside your home, you haven't taken it outside to experiment or play around much, or?
No. This is, you can see this is all inside the house. And here it is. It's flying down the hallway. Perspective is difficult. This is about 15 feet. Flying down the hallway is it's about a meter off the ground.
Do you have any idea how stable it is if there's wind out, like gusty winds?
Again, it's not going to fly outside. It just isn't strong enough. Little bit of air current, you're probably okay. When I did these videos, I turned off the air conditioning. Just I didn't even want that much current. And that's not a lot, but I didn't want any breeze. And I was a little bit worried about that prop wash and that side wash from the walls. It seems to handle that just fine.
Yeah, this one.
The reasons why it cannot fly outside might be that its IR sensor is blinded, right?
That's true too. That's true too.
It's designed for indoor. This one was completely designed for indoors, which is, it's pretty incredible because a lot of the drones are outdoors only, and it's nice to have one that you feel safe inside and just not worrying too much about any collisions.
Yeah, exactly. I mean, all the testing I do is indoors, and I do a lot of the stuff in my robot room, which isn't very big. So, being able to do it, when you're doing something with a robot that runs around on the floor, you have more control over it. Once you set this off, it goes, and it goes fast, even when you're not trying to send it fast. And if you're going to try to grab this in midair, if it's doing something you don't want, you got to grab it, and it's got those rotors going around. You're not going to get hurt, but you could damage the rotors.
Yeah, that's an issue. I mean, how many times have you run after your robot on the ground to get it stop its mayhem? It's different when it's three-dimensional. It's flying.
Yes. I've only had to chase this one once. By the way, somebody was asking about the battery. This is the battery. It goes underneath and it's that wide. It's very small. Flat. It just slides in underneath the robot.
So, a quick question about the IR sensors for your height control. So it's actually getting reflection off of your, it looks like hardwood floors. Any problem with attenuation or scattering or any of that type of stuff with the IR? I take it there's an IR emitter on the device and then it reflects off your floor and picks the reflected signal back up. Is that correct?
Yes. And I don't know the specific details, but it works much the same as those sharp IR rangefinders. And absorption and scatter and all that really aren't much of a problem. This thing is hopefully flying level, right? Or pretty darn level. So when it's projecting its IR down, it's perpendicular. So it's not getting, it's going to reflect straight back up, hopefully. And this just isn't a problem. If I had a jet black floor or a floor made out of black felt, it might not work well. I don't know.
What about do you think it would work much off of carpeting or would that somehow scatter and absorb too much? I don't know.
No, I think it works okay on carpet. The problem that you would run into with an IR rangefinder is if you bounced it off something at a greater than a 45-degree angle, it might not see it. But this isn't going to be a 45-degree angle under any normal flight conditions.
Right, or something that absorbs IR.
Something that absorbs IR, or I don't know. Honestly, I'm not sure what would happen if you did it off a mirror.
Thank you again, Bruce. Appreciate all your answering your the questions we have. Thank you.
Absolutely. Well, folks, if that's it, that's all I have.
It says on the webpage, IR sensors for laser battle. That would be kind of cool. You like you shoot a laser at your enemy's drone and it lands.
Oh.
There is you have to have two drones. You can put them in RC mode or you can still do it autonomously. But there is a battle mode where you can try shooting at each other. I haven't done that, but you can also control these LED lights and make them flash in different patterns and different colors. Kids might like that, I guess. But those are other little details. But the battle drone, that might be fun.
You could use.
Yeah, it'll be a challenge, like like our tag robot contest. It'd probably be pretty. I don't know. It'd be fairly difficult to autonomously, attack another or find it and shoot at it.
You can maybe use that as a kill switch with your own IR laser.
That's true. That's a good point, Ben.
You could actually use it as a laser tag type thing, as a target. It could shoot you and you could shoot it.
How does it see that you've shot it though if the sensor's on the bottom, right?
That's a different sensor.
Different sensor.
Yeah, that's a different sensor. And so I
modulated carrier, so it wouldn't affect his other sensors.
Okay.
Okay, folks, that was my presentation. I'll turn that off.
Thank you, Dr. Bruce.
Thank you.
Thank you very much. Appreciate it.
Another excellent presentation.
Yes, it was really good. I like your friend there, Ben.
Oh, thank you.
That's a full-size one?
No, I think this is the first one.
Well, first one you did was full-size, wasn't it?
It's a little smaller. Then the
Well, is it like
this? I guess you can call it the first generation. The next ones, they're probably closer to that size. How come that one has a belt?
Well, I haven't glued the two halves together yet.
Was it 3 halves?
Well, that's holding the upper and lower torso together temporarily. I want to get everything mechanically working. I'm going to tear it apart and start painting it here in the next week or so.
All right. Yeah, so we have some show and tells. I believe Thomas was first.
Oh, Thomas.
Thomas, where are you, buddy?
There, got my video, audio and video. Can you hear me okay?
Yes, sir.
Like
your background. I got an air conditioner in the back. I'm going to shut that off because that's kind of loud.
Yeah.
Is that even better?
If you could, well, that is fine. I mean, you kind of fade in and out because of your background. But
oh, yeah. I put Sophia up behind me.
yeah, we see that.
Well, there's a reason behind that. So what I'm doing these days is I'm designing my own Sophia Robot. And Sophia, as some of you know, is made by Hanson Robotics. And that's what she looks like in the background for those of you who don't know Sophia. Is there anybody who doesn't know Sophia?
I don't know.
Well, Sophia, designed by Hanson Robotics, has obviously a human face. She smiles, she frowns, she uses AI, like a lot of robots do. She has several modes of AI, including chatbot and intelligentsia and scripted. A lot of it's scripted because AI can be very unpredictable. At least chatbots can be. She is animated. Her whole face is animated. Her eyes, her mouth. It actually smiles and frowns. She moves her eyebrows around. They animated, I think, both her left and right arms, and as of late, she can walk more or less, not well. She uses the same kind of walking that Asimo and some of the other robots use for walking.
Kind of squat.
What's that?
Kind of squat, kind of walk.
Yeah, kind of like they're squat, like they got to go to the bathroom or something.
Knees are bent, I was going to say.
Well, I'm going to design mine in several phases because obviously to do all that at once would be over my head and take way too long. I looked at what they designed and I thought, hey, I can do that. It's just another humanoid robot. And as a lot of you know, I have a lot of humanoid robots. I'm actually renovating Miss, oh, I got to take that off, Miss Betty 9 here. What? Let's see if I can shut this off.
Oh, you're disappeared, Thomas.
Oh, no. Video, hold on. I got to shut off my virtual background. Give me a second.
Your shirt's the wrong color or something.
That's the problem. Choose virtual background, none. There,
hello.
Camera, there we go. So I'm retrofitting my other, there we go, my other fan. So I've been building these things for years and years, and I've been messing around with chatbots forever. And they're not that hard, really. It's just, in a lot of ways, it's simpler than the robots you guys normally build because this thing's built for entertainment. And if it doesn't do AI so well,
that's part of the entertainment.
That's part of the entertainment. So I said, I can do that. I can make this robot similar to my Betty 9 that you just saw. And yeah, it's not going to do everything she does, but it could do 80–90% of what she does. I don't have a team of 14 developers behind me and engineers. So it's just me. Occasionally my daughter, but that's another story.
Yes, it is.
Yes, it is. So I bought some skin to put over my robot. So the first thing I did, version 1, phase 1, the hands are not going to be articulated. So I went out and bought a hand. So if anybody's squeamish about body parts, they should end the video now. Okay. So this is a silicone-based rubber, and it can be bent and it cannot be articulated. That's phase 2. I'm going to articulate the hands with the skin over the top. That's going to be a challenge, though.
I can help you with that.
Yeah. So, and I bought something to put over. I'm going to either use Betty Nine's head or one of the Elvis robot heads. A few years ago, for you guys who don't know about the Elvis robot, there was an animatronic full scale, well, life size up to the bust here of Elvis Presley. I bought a bunch of them. I bought 63 of them.
Yikes, that's a lot.
I've still got about 20 left. So they're animated. The eyes look up, down, left, right. It opens and closes its mouth. The head goes left, right, sideways. What's that, Tim?
He's got a lip snarl.
Yeah, it's got the snarl too.
Thomas, where do you buy the hands from?
Online, they're generally coming from China. There's a few here in the United States, but
Now, did you get a left and a right, or just a right?
Or 2 rights by accident.
Does that answer your question?
I can't see. Someone switched screens. Hold on. Where are you? Oh yeah, you got a left and a right.
Yeah, right here, right here. Okay.
All
And I've got some.
Why did you buy 63?
Because that was the deal, 63 or 0.
Those are from Sharper Image originally. They're an Elvis.
Originally Sharper Image, that's right.
He bought out of stores leftover returns and things and what was left over.
That's right. I bought them as is, and believe it or not, 10% worked perfectly, and the rest had various problems with them. So then the face comes. So what are you going to do for the face? Well, I thought, maybe I'll find some beautiful woman and cast her face. My wife already said no, so that left her out. My daughter says, "Are you kidding?" And that left her out. My daughter's 14 now, and she wants nothing. She used to be really big into robotics. Now she wants nothing to do with robots. Go figure.
Oh well, sounds like she's working her stuff up into boys or something.
Well, things change as they get older. So I said, well, what are you going to do for the face? Am I going to cast one? And I looked into casting. Am I going to take some famous person's face and cast that? Because you can get these molds online of famous characters, like famous actors and actresses. I could find what's that actress's name? Not Elizabeth Hurley, the other British one. Anyway, so I said, no, that's just too much trouble. And I was looking around on the on Amazon for different kinds of silicone, and this mask popped up.
Where'd you get that?
Yes, and so This is silicone rubber, not silicone, and it's over the top of my other mannequin head, the one with those electric eyes, the snake eyes, and this I can put over an Elvis head.
Have you tried it yet?
I have. I've had it over the top of Elvis. It's very flexible. You get them for about $150 up. Yeah, they're not cheap.
Yeah, there's a whole, yeah.
And that's going to be phase 1. And the next thing is taking the Elvis, trimming it down so it looks like more like a woman than a man. I need to find some artists because I'm not a sculptor. I'm just going to take probably
I found something. Thomas, I found something you might be interested in. I found a lady that already is doing similar what you want to do. She already has a face mold and everything you can download and 3D print, including the mold for the face.
Send me the link, Tim.
I already did, but I don't know if you got it or not. I was thinking about doing it at some point, but not right at the moment.
Okay, Tim.
Would save you some time.
Anything to save time would be great because I'm still working. Yay!
So am I.
So I have also the legs on the way. The legs are not going to be articulated, so they're going to be static. The Elvis was going to animate her head, and I'm going to animate one arm to start with, just at the elbow, so she can gesture while she's talking, you know, kind of like my Italian grandmother used to do, like this, you know, hey, what's the matter for you? So,
Oh, you had an Italian grandma too. Same here.
yeah, the full mother's side of the family. Grandfather spoke no English at all. Never
Really?
understood a word he said. Anyway, the head is going to be fully articulated. The one arm is going to be articulated. The face, like the Elvis, is going to have eyes that go up, down, left, right, eyebrows close and open, left and right independently. Mouth opens and closes. It's going to twist, nod, and from here down, it's only going to have the elbow working, and that's phase one. The legs will be static. Again, Hanson's barely got his working. His barely works. I was looking at the videos just this evening, and it's not great.
Well, as far as what his technology is, it's still servo driven, and in my opinion, he's still behind what's really practical. But again, he's still working on it.
Well, I'm working on what I can afford, Tim, and this is what
I understand that. I understand that. The only thing I think about what Hanson did is come up with his own audit skin. It was a lot nicer skin material than silicone.
I'm sure he has, but you know, I've already put about $200, $300 into the silicone. I'm probably going to put another $300 into it, and that's where I'm leaving it, Tim, because you know my wife's going to start asking me about these you know, full-size dolls I got in the robot room. She's anyway.
Well, okay,
it's going to use several. It's going to use several Arduinos to control the motion. It's going to use an Amazon Echo for the voice recognition. At least I'm thinking of Echo right now. It could be something else. Let's see. An Easy Robot board. I'm going to go with the Easy Robot because with Easy Robot, I get a lot of AI built in, visual, really good voice recognition. I get facial emotions I can get from it. I can find out how a person's feeling that day. I mean, it's pretty simple, right? Is he smiling or frowning, right? Is his eyes like this or like this? Anyway, and a Windows PC. Camera, a microphone, a lot of sensors, including a video board, either the Husky lens, which I'm trying to, oh, by the way, I got it working. I got the Husky lens working. I remember, if you remember last time, I was still having issues with it. But
that's cool, Thomas.
Yeah, and thank you, Tim. And where was I? And, or the Javois video board, one of the two. I'm going to probably use those or see how good Easy Robot has gotten. I haven't looked at their stuff in probably a year, so I'm sure they've got upgrades. Anyway, that's my next project. I've started on it, and yes, I got the Husky lens working. Would you guys like to see a demo of that? I don't have it set up today, but maybe another day.
Another day, because we're kind of running late.
Oh, and I'm just going on and on, aren't I? All right, that's about it then. Thanks.
Thank you, Thomas. And next, I believe, is Jim. Jim, you got the floor.
All right, thank you. I just wanted to talk a little bit about the what I've been doing in robotics lately, which is the taking this course that I mentioned from Udacity, the robotic software engineer micro or nano degree program. Can you see the my screen now?
Yes, we can.
This has been really good, and they've had a free month of subscription that you can get. I didn't check. I should have checked before this, but as of a week ago, it was still. They were still allowing people to sign up for a free month. And then even after, I didn't finish in 1 month, and it was going to be like $400. So I called up to cancel. And then they said, oh, well, you can pay $99 basically per month. And then if you finish it in 1 month, then it's only going to cost you $100. So I went ahead and did that because I really enjoy this. But it's not like this as expensive as it says. And furthermore, you could finish it in a month if you really have some time on your hands, or just dedicate to it. A lot of people are, but 2 months certainly. I mean, I'm not gonna go past that for this particular one. But the syllabus has some really cool stuff. It's got ROS, which I've been wanting to learn. Here you can see Gazebo is this really cool app in ROS that shows you the simulated environment. Now I have a video of what I've been working on. I built a model of my big orange robot inside the ROS, or in the Gazebo world. And so they teach you the essentials of ROS. I'll just go over this quickly. That was really cool, learning about all the topics and the messaging and how it works, and a very basic overview and exercises. But the main part of the course is like localization and mapping and SLAM, as you see here, and then path planning and navigation. And I'm just finished this localization chapter, which uses this thing called Monte Carlo localization. And it's really interesting, and they explain pretty well. And they have these short little videos and their diagrams, and pretty well done. And then I definitely wanted to, learn the background of, again, or in more detail of mapping and SLAM. I mean, we've learned a bit here and there, but it's nice to go through the exercises yourself and do it like kind of get down to the nitty gritty of it, and the path planning as well. And then you're doing a little project, so it's pretty cool. So now let me, I'm gonna share a different screen here. How do I just share? Okay. Do you see my desktop now?
Yes, we see your desktop.
Okay. So okay, so here, do you see the my video playing?
Yes.
So this is the first edition of my orange robot. I made him a little bit better than a little bit smaller. He's too big here, but this is showing you on the left side is Gazebo, the simulator. And I have built an environment here with walls and chairs, and I've made the chair myself using the model editor of Gazebo. I guess what I'm showing here though is one of the projects was to chase a ball using just the video feed. So the robot will chase the ball based on this video feed, and this is a simple plug-in program in C++ that you write. And in this case, it's just looking for these white pixels. It's nothing that you could use in the real world, but it's a start. And so the video, with Gazebo, you can put a camera, a virtual camera on your robot. You can put a virtual LiDAR, and then it sends virtual lasers out, and it's really pretty impressive, the amount of simulation it can do. And then of course, this code, once you've got it, if you have a real robot, you can move that ROS code over to the real robot. But in this case here, it's just it sees the video of a white ball, and it turns left or right and moves towards the ball. And but it's just kind of cool satisfying to do this, to accomplish, with not huge amount of effort. But yeah, that's basically what I wanted to show you. And if you have any questions, I'll be happy to answer.
That's pretty cool, Jam.
That's really nice. You're doing the hard work. Hard work.
Yeah, and so yeah, and I'm also working on the real robot. I've been working on Python, moving everything over to Python on as Dr. Bruce has done, and over a year ago. But I'm a little late to the. But I'm moving it to Python, and I've already have the Google Assistant code integrated on the robot PC, basically. So that so it'll be able to answer questions from the cloud, and then I'm going to write the code that intercepts the text. It's a speech to text, and it will decide whether it's a command for the robot or a command or a question to the Google Assistant. What time is it, or Dr. Bruce's favorite, how old is Abraham Lincoln? I like that one. Or turn left 90 degrees. So that's that. I'll hope to demo that in a future meeting. Well, thank you.
Cool, Jam. Thanks. Thank you. All right, Sergey, you're up.
I just unmuted myself, and what I'm going to do is I will post the link to my okay, here it is, to my photo album, which I will be showing and explaining what it is. But if you have difficulty seeing the videos from it, or just want to browse it slowly, it's the link, so you have it in the chat. Now, would you mind letting me share the desktop?
Go right ahead. You should be able to do it. Like Bugs Bunny or
something. That's share screen. I'm very unfamiliar with it.
It should be, there you go. That's it.
Okay. Okay, so what I'm working on is I'm trying to robotize the zero-turn lawn mower. And for those of you who didn't move to Alabama yet, this is a little tractor, and it has a 20 horsepower engine, which is a lot actually for this size and for the jobs it can do. It can, for example, tow a trailer from, the usual small trailer that you usually tow by a car. And it has scary looking blades, 3 blades actually, and it mows 52 inches of grass when it goes forward. So you can see here my son enjoying it. And you probably see this picture a lot in California. Obviously, people are using it. So what do I do to robotize it? Of course, I have to move those levers back and forth. And for that, I had to invent some kind of a strong servo. And you can see the process of kind of making the prototype of the servo. I was using a wiper motor from some old Jeep. I bought 4 of them for cheap, and they are strong motors. The disadvantage of these motors is that they have, first of all, you have to open them and remove some contacts and rewire them, which is not a big deal. But the big deal is that one of the motor sides, motor contacts, is the body of the motor. So when you connect it as a servo to some kind of controller, you have to make sure that all the appliance here is isolated from the ground of your lawnmower in this case. So otherwise you wouldn't be able to control it. So I did that. Ultimately, this is a little device that people use for, let me bring up a bigger picture. People use for sensing the magnetic field direction, and it gives you basically rotation with the precision of 0.1 degree. So when you put it against a special magnet, it will and rotate this body of the sensor against the magnet, or the magnet against the body. It will give you exact position of the magnet. So what I did is what it is doing. Okay. What I did was sorry about it. Some probably interaction between the Zoom and my screen. What I did is I put a magnet towards the back of that gearbox, and the sensor goes in the back. It is very close to the magnet, and obviously there is Arduino and the little H-bridge controller that drives the whole thing. So this is how it looks like when assembled, almost kind of the final version. And the schematics is very simple as well. I mean, we have Arduino Pro Mini, we have the magnetic sensor MLX 9316, and we have the BT2 H-bridge, and that's pretty much it. So that makes a very nice servo with a lot of power. I didn't measure what exactly it can move, but it moves the levers of the lawnmower pretty easily. So when I had two of those servos, I started basically modifying the lawnmower to be able to kind of connect with the servos. And I put two rods. This is how it looks like. Let me see. I put two rods to the front of the lawnmower, and I put an isolating platform made of plywood, obviously. And you will see how it looks like later when it is assembled. I had to print some parts. The servo obviously have to move the rods, and for that I made a cable-based, pulley-based contraption. I printed a couple of kind of ends here, a couple of things that basically correctly direct the rods. And this is how it looks like in the early stage of assembly. Can you see what I'm showing on the screen? I have no feedback.
Yes, I love the sticker.
Oh, absolutely. I mean, I have 3 of them left. I stole a lot with permission. Thank you, Walter.
If you need more, let me know. We got new ones.
We'll ship
well,
them out to you.
I'm fine now. What I'm, dedicated to is obviously promoting RSSC.org in Alabama now. Yeah.
Yeah.
Very good. Very good.
Yeah. So there are a couple of things that I had to add, obviously. And this is how it looked like for the first test. So what you see here is obviously two servos. Each of them has a pulley and a cable, and they move the rods back and forth. Rods are connected directly to the other end of the levers, so that makes a very solid connection. So there are two of them looking in opposite directions, obviously. There is a little distribution panel here that has a switch, and now it has an amp meter and voltmeter located here. And it's nicer now, obviously painted and stuff like that. There is a little bit of, 12 volts and ground distribution panel here. You have to make it so that it shakes a lot and doesn't, disintegrate when you go over the field for hours and hours. And there is a little RC receiver here. Obviously, it will be at the first kind of iteration for testing. It will be RC controlled, and I'll see how well it goes under RC control before I make it more or less autonomous. And of course, this is how it looks like in the field. You can see the lid is open at this point, and I'm holding the RC controller. Very nice quality RC controller for very cheap, actually. And
So you got to be able to be controlled by RC?
Yes, absolutely. I mean, it was obviously a first try, and I was holding my cell phone in one hand and
Trying to drive with the other, yeah, I got you. It's hard to do.
Hard to turn, but if you look at this video, obviously you have a link to that whole collection. You will see that it's
Oh yeah, cool.
controlled and
That's cool, Sergey.
Okay, so there are two videos of that thing, and there are more photos here. The difficult part was actually to control the throttle. I spent a couple of weeks lately, after I made that first cut, with just the two levers. Obviously, you have to control the throttle because, you want to have it idle or full throttle. So it takes quite an effort, a lot of force to rotate that little lever. And here you can see that lever lifted from its base, disassembled a little bit, and this goes to the engine. And I'm connecting a little contraption here, making a little contraption here so that there is a shaft here, and it can be forced to one of the positions using that shaft. And you can see in these pictures here how the shaft is kind of fit. And I printed the pulley here. And this is the final version that actually rotates the pulley and moves the throttle. So now I assembled everything and RC control is connected. I have a switch that is controlling the, let me probably show you that switch. Okay, anyway, I have a switch that controls the cutting mechanism. So basically I can turn and on and off the blades using radio control. And I was about to have a good run today with all the functionality under RC, but I had to figure out how to mix the movement of the RC sticks into the movement of levers. So that RC control will become comfortable for me. So I have to spend some time. The standard mixing doesn't seem to work just fine, you know, so I have to make it right. And I will be putting more pictures here as I go. If you are interested in the progress of this project, please subscribe to that album. You can subscribe and you will be notified when I post new pictures. And obviously I will be at some point mowing some grass using RC. I don't know how precise it will be, but you know, you have to try. The end game is actually to supply it, to equip it with the Jetson Nano or Xavier or whatever I will put my hands on. And I will have to limit its movement in the, you know, GPS coordinates, and probably use some algorithm to scan the field, mow it intelligently and nicely. And what's important, without me sitting on it for 3 hours at a time, you know, it's a pretty difficult exercise. And let me answer your questions.
That's pretty nice, Sergey.
Very cool.
Yeah, excellent.
Thank you.
Thank you.
Cool. Sergey, on the mixing, you can use if you want, you can use a single stick to control left and right if you mix the aileron and elevon. Anyways, look it up. There's a.
I already tried it. You know,
oh, okay.
I kind of come from RC airplane.
Okay. Okay. All right. Good.
Like 15 years flying RC with my kids, which was a lot.
Oh, okay. So you already know about the mixing.
I'm very familiar with that part.
All right. Cool.
So my point is that when you start mixing it in the transmitter,
yeah,
there are funny positions of the stick that are completely unnatural.
Yeah.
So it is natural for the model, you know, for the
right.
elevator mixing, but they are not natural for the tank drive.
Right, yeah.
Boards that can mix it on the receiver side.
Mm-hmm.
And I probably will end up either buying this board if it is kind of available and I can buy it for cheap, or I can use Arduino to do the mixing, to do the mixing exactly as I want.
Yeah.
And what I want is the right stick will be levers, you know, the drive.
Drive, yeah.
The left stick will be a throttle.
Yeah.
So that I kind of get used to that aircraft type of control. But thank you for your suggestion. That is interesting topic. Yeah.
Yeah, yeah, it's really cool.
Sweet.
Can't wait to see it working.
Sorry?
Yeah, keep us updated.
Oh yeah, I mean, subscribe to the album. That's the easiest way to get updated. And
I
I
didn't know you
will
could subscribe to albums now. I thought it was just videos.
follow the link that I posted in the chat room. And then there will be a button, subscribe.
All right, thank you.
Okay.
Thank you, Sergey. You can
But I
stop
will
sharing.
I will be posting into the email thread. Thank you.
Thank you, Sergey. To stop sharing is at the top of your screen.
Okay. So basically, I can just grab it for the rest of the meeting, right? If I don't voluntarily release.
Well, I can stop it from my end, but
stop share. Okay, I found it. I'm so unfamiliar with it.
there you go. All right. Was there any other show and tells?
I'd like to show something if I can.
Sure, if you can do it quickly. We're already half hour past.
Okay, I can do it quickly.
Okay.
I've been working with this modem, this website on a chip thing, and I got something to get. I don't have it all wired up yet, but I can show you what I'm going to have make a little car move around. So I'll show you what a base looks like.
Cool.
Can you guys see that?
Yep.
This is the board. It's basically a web server on a chip, and I already got it programmed to control this, which will move the motors around. So I'll be able to steer it around and stuff. I've got it hooked up yet, but I will before the weekend is out.
Oh,
get it
okay.
all up and running. So by the next meeting, I can show you guys working.
Cool.
It's my new work area. All right.
Very nice, Sam. Cool. Thank you.
Yeah.
All right, guys. If there isn't anything else, we can end the meeting here. We went over half an hour, but it was a good meeting.
Let's see, Ben?
Oh, yes,
Yeah.
Bob. I think you were,
You
yes.
had me on the list there.
Yes, you are. Sorry about that. I
go for it, Bob.
Go ahead.
But if it's too late, I could come back next week or.
If it's a short presentation, maybe we can fit you in.
Well, I could make this short. Yeah, I'll speed through it. All right. Let me share the screen. And I will go right there. And I will make this short. Okay. I am growing food for the Mars project. I will be working with 4 interns, high school kids this summer that are part of the Boeing internship program. So there'll be 2 designers or 2 engineers from Boeing and 4 high school kids from 4 different high schools. And we'll be doing everything at a distance. And so what Boeing wanted me to do was to present a project that was related to STEM. So they knew I was working on Mars. So all of us are going to focus on robots helping us put together a Mars garden here on Earth that could be a prototype for Mars. So here we go.
Oh, sounds cool.
So I'm going to work with Anastasia Stepanova from Moscow State University. She went to college to work with robotics, and then she is part of the astronaut training program, cosmonaut training. And her specialty was, of course, working with plants, robots, different things like that. So she'll be working with me, and then everyone else will be an American working with me. So here we go. So the idea is, can we grow plants on Mars? So I want to involve my 3 humanoid robots. So you all know I work with the Now robot, and we've got the Now robot as actors in this movie, so to speak, or documentary. So the idea is Mars is a very, very cold place. So we're going to have to build a dome and put everything inside. So here we go. So because I'm working with Boeing, I get to kind of follow their plan for Mars, which is really, really cool. In the past, our interns could go right to Boeing and work all day long for about 6 to 8 weeks. But because of the virus, we can't do that kind of thing anymore. So we can't go into work and work side by side with anyone when you're an intern. You kind of have to do all of this at a distance, and that's why I'm involved, to try to figure out what's the best way to work with all these people from a distance. So normally I would work with 10 kids in a NASA Tiger team every summer, but because of the virus, I can't do that anymore. So Anastasia will be in Russia the whole time, so we're communicating from the United States to Russia on a regular basis as we try to work together on a team. So here are my players. There's my scientific equipment, and there are the rest of my players. And the red one was the one I would borrow from Walter from time to time, because we're on lockdown. I haven't seen Walter in several months. So each one of these people will keep a journal the whole time to document all of the work that they're doing. And they'll all have all of the equipment that they need for this project. And then we'll get into working it out mechanically with human beings and then turning it over to my now robots to press those buttons. So we've got special tools to grow our seeds. And then there's all kinds of different combinations that the other people are doing. And the whole idea is to put together our Mars garden, as you can see. And we're starting to bring the robots in different configurations to do different jobs. Now, how do we grow food for the Mars colony? And this is how we do it. This is my dream. That's how I would grow food on Mars. Those are robotic gardens. And working on all different time zones. But I've got all of this played out on my front lawn. I'm growing real food that I'm eating. I've been eating this stuff for about 12 weeks. So this is real. So every 10 minutes, my plants get a little shot of water. So this is the little unit that we put together to house all of the plants and to allow water to flow from one section to the next. So the idea is on Mars, if we need more of these, we 3D print them. So we're going to 3D print them here on Earth so we can practice what would happen on Mars. So I will go quickly. Walter was kind enough to design this robot, and for the last 5 years, I've been using it to train my students on building a robot from scratch and then having the robot do extra jobs. So, of course, we were going to graduate to the Raspberry Pi for this project. And then we're going to build a control center that will control those robotic plant units. There's our parts, and this is the basic unit before I start planting anything. So that's our little robotic garden. So here we go. And as you can see, I am turning out a banner crop for a guy that's not a farmer and I live in the city. So hopefully, if I can do this on Mars, I'm going to survive.
Is that lettuce?
Yeah, because I eat lettuce every day with all of the meals, I have a wide variety of just lettuce. There's a little bit of spinach sprinkled in because my daughter wanted spinach smoothies. So the spinach is on this one. And you can see I'm truly in my backyard, front yard doing this. And I will
go ahead.
I'll go quickly because of the time.
Where'd you get those vegetable pots? Yeah, where'd you get those?
I got the initial vegetable pots from an organization called Lettuce Grow. And then I'm going to duplicate those so we can do those with 3D printers, but we have to do a modification so we can get the electronics in there. So this is the real deal. I'm really eating the food that I'm growing on a regular basis and trying to come up with a big, wide variety of food for the astronauts.
I remember one of the projects that I did for JPL was very similar to this. I designed the robot that would go to Mars. It carried all the equipment that it needed, including a little greenhouse that it would assemble, and had a scooper that it would put soil into the little greenhouse, and then it would plant the crops in there. The entire greenhouse was heated by solar panels.
Well, you got to dig up that project and turn it over to me. I'm ready. I'm ready to check that project out.
So,
okay.
Interesting. That's interesting. You were breaking up there, Ben. I didn't hear much what you said.
Oh, was I breaking up?
You were.
Okay,
so
somebody had a question?
Yeah, Bob, this is Buzz. What is the robotic part of all of this? Obviously, the biology is interesting. What kind of robotic activity is involved in this project, actually?
Well, one of the things I have to do is I have to send a signal to my robot to actually press some buttons and throw some switches. So that would be the first activity, dealing with communication going from mission control to my first humanoid robot. And then another situation of, and I passed the slide, several slides away where I had the little control unit, is to send a signal to my control unit. So to help me with all of the radio communication, what Boeing did is they assigned 2 engineers that are working on the Orion project, and they're sending signals, of course, from Earth to the International Space Station, from Earth to the Moon, and then from Earth, of course, to Mars.
Oh, that sounds cool.
So so we're in that phase there. So my job was to make sure that this worked on Earth and we could get some high quality plants before we made the big investment in robots controlling something.
So in other words, the now robots would do the button pushing, and you have a communication system in order to instruct the robots to, or the now robots to essentially do what they need to do then, if I'm hearing you correctly.
Yes, yes, because my now robots have a wide variety of audio commands. I can actually speak through a speaker and command my robots.
Okay, so they have voice recognition capability then.
That's right. They have voice recognition and also facial recognition. So what I could do is I could show an image to these robots, and the robots could do a series of projects. So one of the images, it would be the plants in a condition where they need water. So the robot takes a look at that photo of a plant that really needs water, and he can take that command and go to work. So what I'm doing is I'm constantly taking these photos. You notice how I'm taking photos of plants that are really, really healthy. And then I have to have a sliding scale of when a plant looks really bad.
So you have
and
to
hopefully
force the plant to go from looking healthy to looking bad so you can get pictures of it.
That's right. That's right. So did I answer your question?
Yes, very much so. And I thank you for taking the time for that. So you're using essentially, healthy samples versus non-healthy samples. The robot then interprets that kind of thing, takes the appropriate action. And I take it autonomously or just through your control ultimately?
Well, ultimately, we'll be moving towards autonomous robots. So we've got a lot of ways to take facial recognition in cameras and have those things pose as robotic stations that are stationed right next to one of these white towers. So part of the whole summer internship program is for me to put questions like you just asked on the table and get answers.
So is now space rated for low temperatures on Mars?
Oh, no, none of that will be real, of course. It's so freezing cold on Mars, you won't even be able to get me up there doing something. So, but what we're trying to do is just to kind of simulate the scenario on Earth, knowing that once we go there, Boeing has enough money to do this thing the right way.
Yeah, you're building a prototype system is what you're doing, and that's great. Looks terrific.
Yeah. That's the best I can do, because you got to remember, I've been on lockdown for 12 weeks. I can't even go to the store and get parts.
Well, electronic stores and those things are open.
Yeah, I know they're open, but I'm paranoid of leaving this place. So, because I know what it's like to have that ventilator tube down your throat. Just the thought of that.
That's fine. I am in a similar condition, but if I need to go somewhere, you know, I will mask and glove up and go.
Yeah,
I have to.
yeah.
So, you know, because I'm working now. I'm working, you know, 5 days a week now. So.
Oh yeah,
Bob, you need to use your NASA spacesuit to go out and do your shopping.
You are absolutely right, and I got the suit. Okay, let me keep moving here, guys, because I'm killing your time. All right. So now there becomes the issue of the seeds. Getting the seeds to be strong enough to move to the next level. Once I get the seeds to be pretty strong the way you see it right now, then I can move it into my big white pod. So now I have to get the robot to be able to lift the seed from this situation and stick it into the other situation. So this is all part of the research, and here's my little Long Beach Unified School District crew that's helping me with this. Some of the crew members are here. They're taking real good notes. It's turning out to be a great school project from a distance, because I can't sit in a classroom with these guys anymore. Everybody's at home. So they got to take, so this is the last time we were together in a classroom. So nobody's doing that stuff anymore. So everybody's at home, like this guy. And I'll keep going
that's
here.
Cool. That's cool. I like that.
What's that?
Flowers, yeah.
Oh, yeah. The growing of the flowers is part of the psychological thing. You're on Mars, everything's cold and dry, and
well,
it's a desert.
Ultimately, all the stuff's could be inside a pressurized dome, isn't it?
That's right, but still, it's when you look out that window.
Oh, that's true.
So here it is, and here they are, side by side.
Oh, that's cool. I like it. Wow, you've been busy, man.
Yeah.
Really good growth. I mean, I have my own little garden back here, and it's not, you know, it's not that easy.
No, it's not.
So the brand new Raspberry Pi that just came in, you can see the specifications. Now I got the firepower to do what I need to do. The Arduino just can't take the heat. So
it sounds to me, Bob, when this problem is solved by having the robots actually manipulate things, recognize what they need to grab, move, relocate, and manipulate. When this problem is solved, this will be one step closer to the robot that goes to the refrigerator, grabs the beer, and brings it to you, right?
That's right. And I have never participated in that contest. So, but I learned from those contests of the club members doing all of those things, so I can reimagine what these robots will be able to do. So there's one of our astronauts in training. This young lady is 18 years old. she's going to college in Florida. And her special part of the experiment is she has a special chamber that simulates the atmosphere on Mars. So when she's doing her work, she'll be able to work under those conditions and give us that real-time feedback. So that's it. And I want to thank you guys. I know it's past midnight, but thank you for letting me have this show and tell.
Well, thank you for sharing that, Bob. This was really interesting and really appreciate your doing it. And thank you, Ben, for allowing him to do it. Appreciate it.
Of course.
Yeah, it was good. It was good. Good, Bob. I didn't know that's what you were doing at home. That's pretty cool.
Well, thank you. Thank you very much, guys. I sure miss the days when I could go to the club because I don't know what we're going to do with our annual pizza party. Is Walter going to make a delivery to all of our homes?
Everybody has to order their own pizza.
I know.
Oh, no,
No barbecue in Riverside this year either.
You get a drone to deliver it.
We'll deliver one for Sergey also, all the way over there.
Yeah.
We'll call Pizza Hut over there too.
Oh yeah.
All right, guys. That was a great meeting. Thank you, everybody, for showing up.
Thanks.
Yeah, great. Thank
Hopefully
you.
I get my little car going.
Thank you, Ben.
You got it. So the next meeting is when?
2 weeks from today.
2 weeks, right? So that's the 26th.
Yep. 20.
So see you guys on the 26th.
Okay.
Have a good,
Okay.
productive, and
See you
safe.
then. Bye-bye.
All right. See you guys later.
Ben,
Yeah.
before you go, please remember to contact Oscar about the paper plates.
Oh yes, I will. I'll probably have it by next meeting.
Okay. Or if he's, if he furnishes it to you, is there a way you could just simply post it on the site somewhere?
That would be the ideal. And if when he does, I'll make sure to ask permission to post it on our site.
Sounds good, because that was a really interesting talk, and I'd love to learn more details from it.
Oh yeah. All right.
And you okay? I haven't heard from Alan.
Oh, Alan, he's working on a fence in his house, so he wasn't gonna.
He's not really here. That's. I thought he was kind of frozen.
That's a static image.
That's his robot.
Right.
That's virtual Alan.
Well, I'm sure learning some cool things about the Arduino at work, guys. So doing some cool stuff with some other processors.
Cool. He maybe want to do a show and tell next.
Well, I don't know. We're working with this Artemis chip that's SparkFun is spun into a board. I can't really tell you what it's going into, but right now I'm just trying to get 3 or 4 things, 4 or 5 things to be controlled simultaneously, and it's very interesting.
Sounds interesting.
And making these Lynx Motion serial servo motors run with just using the soft serial thing was pretty cool too.
All
because
right.
the library wouldn't work with the board I was working with.
Thomas, you better be wary of that hand. If it gets a mind of its own, it might start spanking you if you're a bad boy.
Oh no.
Yeah, watch that, Thomas, man.
All right, everybody. Have a good night.
On that note,
Thank you.
Have a nice weekend, guys.
Let's end it with that note.
Have a nice weekend,
Thomas
everybody.
getting spanked.
Bye. Bye.
Good night, everybody.
Night.
Stay
Bye.
safe.
You too. Bye.